Hey y'all, so today we are going to review a topic that you learned last spring in eSchool. We are going to review limits. So today's just an intro to limits. We're going to start with a do now, which is a warm-up kind of for what we're talking about each day, or also just like review of things you need to know for calculus. So usually use the equation for f of x and the graph of the function to analyze completely. Okay, so the first thing it tells us to do is to factor f of x fully and simplify. If you aren't sure how to factor this, let's just really quick go through how to factor that. So I like to use the box method, and then I like to put what we need to multiply to, what we need to add to. We need to multiply to a times c, so 3 times negative 3, negative 9. And then we need to add to b, so add to negative 8. All right, we always put the first term, 3x squared, in this part of the box. We put the last term in this part of the box. And then we need the two numbers that multiply to negative 9 and add to negative 8. So I'm going to do negative 9 and positive 1 and throw some x's on there, because those multiply to negative 9, add to negative 8. Then I pull out a greatest common factor. So on this line we have 3x, on this line we have 1, on this line we have x, and then on this line we have negative 3. Okay, so this top part factors to 3x plus 1, and then x minus 3. And then the bottom part factors difference of squares. You get x plus 3, x minus 3. Okay, cool. And then it says to simplify. So how can we simplify this? Cross out the x minus 3's. We get 3x plus 1 over x plus 3. Okay, so that's fully simplified. Now let's talk about the whole. So if y'all recall from pre-calc, a whole happens where you cross out common factors. So the whole happens at x equals 3. That's where that whole happens, because we have to switch the sign. So the whole happens at x equals 3, but we need to find the coordinates. The coordinates are the point. So that means we need to plug in x equals 3 into our simplified form. So we're going to plug in 3's for x, plus 1 over 3 plus 3 equals, that's going to give us 10 over 6, which equals 5 over 3. 5/3. So this is our y when x equals 3. So our point would be 3, 5/3. Okay, cool. So that's the point where the whole happens. So if we wanted to put it on our graph, or if we wanted to look at it on our graph, you can see that it happens at 3, and this is 5/3. Cool. Domain. So the domain of this graph, we go all the way from negative infinity to, and then we have to stop at, let's see, negative 3, right here where the asymptote is. So negative infinity to negative 3. And then we get started up again at negative 3, because we can't touch this, right? That's why we have to do this kind of split all the way to the domain, again, goes to positive infinity. Remember, domain is the x values. Range is y values, and we start at the bottom. So we go as low as negative infinity. So I'm going to put that over here, negative infinity. We have to stop at the horizontal asymptote. So that happens at, actually we have to stop at this. We have to stop at this point first, because there's a hole. So we have to stop at 5/3 union, and 5/3 going from 5/3, now we say how high do we go to the asymptote? Up to 3. And going back to the asymptote, 3 to infinity. Sweet. All right, last thing, vertical asymptote, or last two things, sorry. Our vertical asymptote happens at x equals, it crosses the x-axis, so that's how you know you're going to write x equals -3. So that's our vertical asymptote. And our horizontal asymptote happens to cross the y-axis, and it happens at y equals 3. So we're going to put that there. Y equals 3. Sweet. Okay, let's move into notes. So now you're going to need your notebook. Make sure that you quickly get your notebook out, get a pen ready to write. Okay, we're going to do intro to limits. So make sure you write 1.1 notes, intro to limits at the top of your page, and then let's talk about limits. Write this down, all of this. A limit tells you what height the function is trying to reach at a specific x value. A limit tells you what height the function is trying to reach at a specific x value. And then if we're going to simplify it, limits are y values. So quickly write this down as fast as you can. A height is going to be a y value. So if the limit's telling you the height, the limit is telling you the y value at any given x value. All right, and let's review what you learned about limits last year. So remember from pre-calc, there are 3 types of limits. You're going to quickly write down the types of limits. You don't have to make your table look perfect or anything. Just get this in your notes. So we have the right-handed limit, and the way that you write the right-handed limit is a limit as x approaches c, which is some x value, from the right of f of x. That's the right-handed limit. Let's write this out verbally now. So the way that we say this is limit as x approaches c, and then we say from the right of f of x. So limit as x approaches c from the right. And I actually like to say the limit of f of x as x approaches c from the right. So I'm going to write of f of x. Sorry, I'll write that on the other ones as well. Okay, now let's do the left-handed limit. So this one looks like limit as x approaches c from the left. And the way that we're going to write that is we're going to say the limit, oops, I keep wanting to write lim. Okay, limit of f of x as x approaches c from the left. Cool. So that's your left-handed limit. And then you have your general or basic limit. So the way that we write the general or the basic limit is limit as x approaches c. So limit of f of x as x approaches c. Okay, cool. So make sure you get those 3 types of limits down and how to say them. It's important to know how to say them for a lot of reasons. One is for this class, and also for your future. If you take calculus in college, you'll definitely want to know how to say this. So make sure you write that down. All right, now we're going to do some tests. And, oh wait, just kidding. Let's write the formal definition of a limit. So here's the proper notations. Now we're going to talk about how do we know if a limit exists, or what is the definition of a limit. So let's go ahead and write the formal definition of a limit, which says the limit as x approaches c of f of x equals L is only true if, and then two things have to be true. The limit as x approaches c from the left of f of x equals L, and the limit as x approaches c from the right of f of x is also L. So if you wanted to write it out, this limit is only true if we have the same limit. And remember, a limit is a y value, so write that down. If we have the same y value or limit coming from the left and from the right. A limit exists only if you have the same limit coming from the left and coming from the right. Alright, so now we're going to see what that means on a graph, but before we do that, make sure you get this written down. Alright, and let's go to this graph. So in a second, you're going to do a couple of these on your own, but I want to do a few with you and remind y'all kind of what you did last year. Okay, so we are going to, sorry y'all, I'm getting used to this pen. The pen is giving me a hard time right now. So we're going to look at this graph to find the things down here. So first, f of 2. This just means what is the y value at x equals 2. That's like old school. That's not even calculus. So that means let's go to where x is 2 and then look for the y value. X is 2. What is the y value? Do we choose the open circle or the closed circle? Closed circle. Y value is -1. So f of 2 equals -1. F of -1. That again means let's go to x equals -1 and find the y value. X is -1. We want the closed circle, so that's 4. Okay, let's keep going. We have the limit as x approaches 4 coming from the left of f of x. So limit as x approaches 4 from the left. So was it 4 or -4? Sorry. Limit as x approaches +4. So we're going to go to where x is +4. And we're going to put ourselves on the line. So I like to put myself on the line. It says approaching from the left. It says limit as x approaches 4 from the left. So that means put yourself on the left, on the line on the left of 4. So I like to imagine that I'm here and I'm coming towards 4, towards x equals 4 from this direction. What is the y value that I'm getting closer to from the left-hand side? I'm getting closer to 3. So this would equal 3. All right, let's do the next one. So equals 3. Oops, equals 3. All right, limit as x approaches 2 from the right of this graph. So we have, now we're looking at limit as x approaches 2 from the right. So go to where x is 2. Put yourself on the line on the right-hand side. So this is the line on the left-hand side of 2, right? But we're looking from the right. So we need to go to the right-hand side, put ourselves on the line, and we have to go towards x equals 2. So now we're coming this way. We're approaching from the right. What is the y value that I'm getting closer to? 1. I may not equal 1 up here, but I am getting closer to that height. 1. So this limit equals 1. All right, equals 1. We'll do a couple more. Let's do limit as x approaches -1 from the left. So I'm going to do this one in blue. Limit as x approaches -1 from the left. So we're going to go to where x is -1. and then come from the left. This is the left-hand side of the line. I'm coming towards -1. Put yourself on the line. And then what is the y value that my function, that my line is getting closer to at -1? It's getting closer to the y value of 2. So that equals 2. All right. Let's do a right-handed side one. So this one equals 2. Let's do -4 from the right. Limit as x approaches -4 from the right. So -4, there's our x. We are approaching this x from the right. So from this way, we have to get closer to -4. What's the height that we're getting closer to? 2. Same limit as last time. Okay, now we're going to go over a couple tricky ones. So this one is 2. How about the limit as x approaches, let's see, is -1 a tricky one? I'm just going to do them up here. Let me erase this. Sorry. So I'm going to erase these, and we'll go over a new one. Okay, limit as x approaches, let's do -4. Okay, remember, for this is a general limit because it doesn't say left or right. It's just like -4. And the limit from the left and from the right have to be the same. The question is, are those limits the same? So we did from the right. This is the limit as x approaches -4 from the right. We know that's 2, coming from the right, coming this way. But can I put myself on the line on the left? I can't draw myself on here. I can't jump onto the line. So this limit actually does not exist. Because for the general limit to exist, you have to be able to approach the same height from both directions. But this time I'm not approaching the same height from both directions. Let's do another one where the limit doesn't exist. So I'll do this one in this color. Okay, so we have limit as x approaches 2. This is just a general limit. The general limit as x approaches 2. We need to put ourselves on the line on the left of x equals 2. So here's where x equals 2 is. Put myself on the line on the left and go towards 2. Put myself on the line on the right-hand side of 2. The line's up here on the right-hand side of 2. And go towards 2. Am I meeting in the middle? Am I coming towards the same height at x equals 2? From the right, I'm coming to the height of 1. From the left, I'm coming to the height of -1. If these do not match from both directions, the general limit, just like the limit as x approaches 2, does not exist. All right, we'll do one more before moving on. Let's do the general limit as x approaches 4, +4 of f of x. Okay, the limit as x approaches 4, we're going to put ourselves on the line. For the general limit, we have to put ourselves on the line from both directions, coming towards the x value of 4. So I'm going to put myself on the line, coming from the right and from the left. Is the person on the right and the person on the left, are they both approaching the same height? Yes, they're both approaching this point, and they're going to meet. They're going to meet at x equals 4. They're going to meet at the same height. That height is 3, so that general limit equals 3. Okay, let's look at limits from tables, because y'all did learn how to estimate a limit from a table, and this is just a reminder. So limit from a table, first you got to fill out your table. So if x equals 2.9, well, first of all, let's read the problem. Now consider the function right here, f of x equals, complete the table below to find the limit as x approaches 3. So I'm going to write that down. We're trying to find the limit as x approaches 3 of f of x, just the general limit. Okay, so the first step, fill out your table. We have these x values given to us, so we're going to pretend that we plugged it into our calculator, but we don't have time for that right now. So pretend that I plugged it into my calculator. I will give you the real values. So if we plug in x, 2.9, 2.9, 2.9 for all these x's, we will get these numbers, 0.1265. So like we're plugging in these x values and we get the y value, right? So we plug in 2.99 for x, we get 0.1251. If we plug in 2.999, we get 0.1250. At 3, there's actually a hole at 3. So this function is undefined. There's no y value at 3. It's just an empty hole. Then we plug in 3.001. We get 0.1249. 3.01, 0.1248. Again, it's like I'm plugging in these x values and getting y values. Plug in x equals 3.1. We get 0.1234. Okay, cool. So now that we have this, we're going to find these 3 limits down here. So based on this table, what is the limit as x approaches 3? So first let's find where x is 3. That's right here. This is x. The limit as x approaches 3 from the left. From the left means you're on the line, like you're over here, you're coming from the left. This side is left, right? You're coming from this way. So what is it getting close to at 3? What's the y value that we're close to? This is the only one that we know from the left. And it's really, really close to 3, right? 2.999 is super close to 3. So we're going to say the y value, the limit from the left, is 0.125. Alright, now let's do the limit as x approaches 3 from the right. So I'll do this one in green. So we're coming from the right-hand side now. This is the right side of the table, which is also the right side of the graph. So we are coming from the right, moving closer to x equals 3. 3.001 is super close to 3. It's just to the right of 3. Like if you're thinking of a number line, that's just to the right. And our y value is 0.1249. So 0.1249. Oops. Okay, and then let's actually round that up. Let's round that up. How would we round 0.1249 up? That's 0.125, right? So we just rounded to 3 decimal places. In calculus, you always want to use 3 decimal places. So that's a very important thing to know. Okay, and I'll remind you like constantly. All right, and the last thing we're going to do is find the general limit. That was the thing that we talked about in the very beginning. What is the limit as x approaches 3? So here's x is 3. Remember, for the general limit to exist, for this to exist, we have to have the same number coming from the left and from the right. So are our limits from the left and our limits from the right the same? Yes, they are. So if those limits are the same, then you can say that the limit as x approaches 3, the general limit, is 0.125. It's the same y value. And what this looks like in this graph is something like a hole. So there was a hole at x equals 3. So like maybe you had a graph like this and it's all curvy. Oops, sorry. And at 3, say that's x equals 3, there's a hole. And say that this is the y value, 0.125. We put ourselves on the line from the left. And we walked towards x equals 3. We put ourselves on the line from the right. And we walked towards x equals 3. Sorry about my ugly stick figures. And then we realized that they come to the same height. They both meet in the middle at the same height of 0.125. So the limit does exist at x equals 3. Okay. You fill in the blank now. I want you to tell me in your own words, in order for the general limit to exist, what has to be true? And in your own words, tell me what has to be true for the general limit to exist. While you do that, you can look at this. This right here is the general limit. And it does exist here. All right.